de Broglie's explanation of Bohr's second postulate. It states that the angular momentum of the electron orbiting around the nucleus is quantized, that is, Ln equals to nh by 2 pi for n equals to 1, 2, 3 and so on. Why should the angular momentum have only those values that are integral multiples of h by 2 pi? Let us see. From this electron moving in nth circular orbit of radius Rn, the total distance is the circumference of the orbit 2 pi Rn. Thus, 2 pi Rn equals to n times lambda for n equals to 1, 2, 3 and so on, where lambda is the de Broglie's wavelength of the electron moving in nth orbit. Louis de Broglie argued that the electron in its circular orbit as proposed by Bohr must be seen as a particle wave. In analogy to waves traveling on a string, particle waves too can lead to standing waves under resonant conditions. The above figure illustrates a standing particle wave on a circular orbit for n equals to 4, that is 2 pi Rn equals to 4 lambda. Lambda is the de Broglie's wavelength of the electron moving in nth orbit, but lambda equals to h by p, where p is the magnitude of the electron's momentum, that is, lambda equals to h by mvn, as speed of electron is much less than speed of light. So, 2 pi Rn equals to nh by mvn, or m into vn into Rn equals to nh by 2 pi, as 2 pi Rn equals to n lambda for n equals to 1, 2, 3 and so on. This is quantum conditions by Bohr for the angular momentum of electron. Limitations of Bohr's model. The Bohr's model is applicable to the atoms which have configuration identical to the hydrogen atom, like He+, Li2+, and of course H itself. Not even two electron model such as He can be depicted by the Bohr's model because it accounts only for the interactive force between a single electron and the nucleus and not inter-electronic repulsions. The Bohr's model can't explain the relative intensities of the frequencies in the spectrum. It is so because the experimental observations depict that some transitions are more favorable than the others.